this lesson, we're going to talk about 1, 2, and multi-step equations. So we're going to start nice and simple with one-step equations. So here's how you solve a one-step equation. We know that it's a one-step because I'm only going to do one step to solve for the answer. So in this case, you'll notice that I have my variable. My variable is x in my first example here. And I'm trying to get rid of the number that's next to the x. I want to get the x all by itself. So what I'm going to do is I'm going to look at that number that's next to the x, and I'm going to realize that it is a positive 12. So to eliminate that positive 12, I want to do the opposite operation. So I'm going to subtract 12 from my 12. And when I'm working with equations, anytime that I do something to one side of that equal sign, I also have to do it to the other side. And you actually have to show that step just like this. And from there, what I can do is I can go ahead and work out my problem here. Notice how I'm not doing anything to the x, so I'm actually just going to leave him just the way he is. But now I have plus 12 or positive 12 minus 12. That is, those are additive inverses that are going to create 0. So I'm just going to cross them off like this. Notice how my equal sign is right here. I'm just going to go ahead and carry him straight down. And then I'm going to go ahead and solve 10 minus 12. And 10 minus 12 is going to be negative 2. So in this problem, my answer is x equals negative 2. Now, to solve or to check an equation, you can actually take that number and you can substitute it back in for your variable. And if we did that, we would get negative 2 plus 12, and we do know that that is equal to 10. So that's a great way to check yourself. We are going to be doing that check step in later problems. But let's look at the second question here. I have negative 2 equals x minus 9. So I'm trying to get that x by itself. It might bother you that the x is on the right-hand side, but don't worry. We're going to move him over to his proper position at the very end. So I see that I have a negative 9. Let's go ahead and eliminate that negative 9 by adding 9 to both sides. And it is very important to show your steps in this, because as we can start getting into more complex problems, you're going to want to make sure that you show plus 9 on both sides. So negative 2 plus 9 is 7, and that's going to be equal to x by itself. Because of our added inverses, they cancel out on the other side. So I can go ahead and take my variable and just flip it over and have it on the left-hand side. And I'm going to go ahead and box my answer. All right, the next one is 3x equals negative 18. I'm trying to get the x by itself, and if you look, I have a 3 right next to it. The 3 stands as the coefficient of the x, which means that it's being multiplied. 3 is being multiplied by the x. So what I want to do to get rid of that 3 is I want to do the opposite operation of multiplication, and the opposite operation is division. So I'm going to divide this side by 3. Now, whatever I do to one side of the equation, I also have to do to the other side. So when I do the division here, 3 divided by 3 is 1. So really, what I have here is 1x. And that's equal to negative 6. But we don't usually write the 1 in front of the x. It's just kind of like an invisible 1 there. So our final answer would be x equals negative 6. In our last one, we have the variable g, and this time it's being divided by negative 24. All right, well, it's being divided, and we want to do the opposite operation of division. So what we're going to do is we're going to multiply it by that number that we want to get rid of. Whatever you do to one side, you also have to do to the other. And take into account that it is negative, and that's okay that it's negative. And what's going to happen here is this negative 24 and this negative 24 are going to cancel out. And I'm going to be left with g equals negative 120. Now, let me go back one moment and just kind of explain that idea of why I crossed out that negative 24 and negative 24. Here's kind of what it looks like. I'll write it down here. When I multiplied it by negative 24, remember, negative 24 is essentially over 1, right? Any number is always over 1. And then when I multiply it, I'm multiplying it by g over negative 24. When we multiply fractions, here's how we do it. We multiply straight across. So negative 24 times g would equal negative 24g. And then if we multiply the bottom straight across, 1 times negative 24, I'm going to get negative 24. And you can see that negative 24 and negative 24, those just cancel out. So I'm left with a g by itself, which is where this g came from. So a really easy way to do it is just when you multiply both sides, you can just cancel them out. You don't have to do all this cool stuff that I just did down here. Okay, then those are one-step equations. For each one of those problems, we did one step. We either subtracted, added, or divided, or multiplied. So now we're going to bump it up to 2 steps. So this time it's going to require you to do at least 2 steps to answer the question. So in the first example, you notice we have 2x plus 3 on the left. Now, the biggest question is, well, do I get rid of the 2 first or get rid of the 3 first? You always get rid of the number that's not attached to the x first. So we're going to get rid of the 3 first, and this is always the case. So I'm going to go ahead and I'm going to subtract 3 from both sides. Sorry about that, I had a little glitch in my pen. I'm going to go ahead and subtract 3 from both sides. And I'm going to be left with 2x, my 3's are additive inverses, so they're going to cancel out, is equal to 12. Now, that was one step, but you can see that my x is not by itself, so I actually have to do one more step. You can see 2 is being multiplied by x, so I'm going to do the opposite operation, and I'm going to divide it. I'm going to divide it by 2. Divide the other side by 2. My 2 and my 2 are going to cancel out, and I'm going to be left with x is equal to 6. Okay, the next one. Again, I want to get rid of the number that's not attached to the x, so I'm going to go ahead first and get rid of my 9. So I'm going to go ahead and subtract my 9, and I'm going to get 4 equals negative 4x, because my additive inverses over here cancel out. All right, I'm going to keep going. I'm going to go ahead and I'm going to divide both sides by negative 4. And you can see on my right side, my negative 4's cancel out. And on that side, I'm left with x equals 4 divided by negative 4, which is negative 1. I'm going to rewrite my variable so that it's on the left. And I'm going to box my answer. I'm doing everything in 2 steps. Okay. My next question is kind of a weird one. You'll notice that I have an x plus 7 in the numerator and then my negative 15 on the bottom. My tip for you with this one, because it doesn't really have that same rule applying here where you want to get rid of the number that's not attached to the x, because there really isn't a number attached to the x. If you want to consider the plus 7 attached, go for it, because you do actually want to get rid of the negative 15. And I'm going to multiply this side by negative 15 because right now he's being divided by the number that's with the x. So I'm going to go ahead and I'm going to multiply both sides by negative 15. On the left-hand side, that's going to give me 15. And then on the right-hand side, remember, my 15s are going to cancel out, and I'll be left with x plus 7. So you just did one step in the 2-step problem. The next step is going to be to subtract my 7. So I'm going to go ahead and take it away from this side and take it away from that side. So I'm going to be left with x equals 8. All right, and my last problem. These tend to be the most challenging of the problems that we're going to look at. In this first problem here, you'll see that I do have a number that's attached to the x. So just like in the first 2 examples that we did, you want to steer clear of that and take care of the 22 first. So what I'm going to do first is I'm going to subtract the 22 away from both sides first. And I'm going to be left with 3/5 x. And that's going to be equal to 6 because my additive inverses, they cancel out. Now, you see that I have 3/5 x equals 6. Now, there are 2 ways that I could do this, and I'm going to show you both ways. And I'm going to show you the way that most students seem to have a preference with, but if you don't like this way, you can do it the other way. So the first way is, notice that I have a fraction. And anytime I multiply a fraction by its reciprocal, meaning I'm just going to flip it over like this, remember, I have to also do that to the other side. But when you do that, they actually cancel each other out. So the 5 and the 5 cancel out, and the 3 and the 3 cancel out. And you're just left with x by itself. But on the other side, you actually have to do a little bit of math. You have to do 6, you have to multiply it by 5, basically. Ooh, my pen's not working. Okay, I think we're working again. What did I say there? Oh, 6 times 5. Well, that's going to give me 30. And so really I have 30 divided by 3, which is going to give me 10. So I can do that simple multiplication there to give me my answer. Now, the other way to do it, I'm just going to rewrite the problem here and say 3 over 5x is equal to 6. Now, another way to do it is you can do it in steps. You could say, okay, I'm going to get rid of my 5 by multiplying both sides by 5. Again, those 5's cancel out, and I'm left with 3x equals 30. And then you can go ahead and finish it off and divide by 3. Either way, you get the same answer because you're doing, and the first method that I showed you, you're doing the multiplication and division in one step. Versus in the second example, you are actually doing it in 2 steps. So either one is perfectly fine. All right, now we're moving on to multi-step equations. So multiple steps just means that you're doing more than 2. So you could be doing 3, you could be doing 4, you could be doing 8. So let's look at this first example here. The noise that you hear in the background is an airplane. I live near Dulles Airport, and the airplanes tend to go really low near my house, so that's what you hear. I apologize for that. All right, my first example here. Hopefully, the distributive property is just shouting out at you, saying, distribute me, distribute me. You always want to do the distributive property first if you have an opportunity to do so. So I'm going to go ahead and do that. But just like before, I'm always going to show all of my steps as I solve this problem. So even though I'm not using these 2 components right here, I am going to go ahead and rewrite it. Now I'm going to take that negative 8 and I'm going to go ahead and I'm going to distribute it. So negative 8 times x is going to give me negative 8x. And then I'm going to distribute negative 8 into 4, and that's going to give me negative 32. So the first step in multi-step equations is to distribute anything that needs distributed. Now, the second step in solving a multi-step equation is to combine anything that is alike. And I like to start either on the left or on the right and combine everything that I can that is on one side or on the same side. So you'll notice on the right side I have 2 x's. So I'm going to go ahead and take a moment and I'm going to go ahead and combine them. So that's going to give me negative 15x minus 32. Okay. So that condensed my x down, and now I just have a 2-step equation. So I'm going to solve it just like I did earlier. So I'm going to go ahead and I'm going to get rid of my 32 by adding 32 to both sides. And when I do that, I'm going to get negative 60 equals negative 15x. And I'm just going to finish it off by dividing both of my sides by my negative 15. When I do that, my negative 15s cancel out, and I'm left with x is equal to 4, because a negative and negative is a positive. So my answer to this multi-step equation is 4. Now I want to talk about the check step. And the check step is very important whenever you're solving any equations. Even though we didn't do them doing 1- and 2-step equations, I wanted to save it till now to show you why we do it. What it means is if you notice that I have x equals 4. X equals 4. 4 is the only number that I could pop into this x right here and this x right here in order for the right-hand side of the equation to equal the left. It's the only number. There's no other number that you could put there to make it equal negative 92. Now, there's a great way to know if you got the right answer, because maybe, you can make a mistake. So here's what I'm going to do. I'm going to go ahead and I'm going to rewrite the problem just the way that it is. And now what I'm going to do is I'm going to substitute a 4 anywhere that I see an x. I'm going to use my parentheses, because remember, they're always free. And what I'm going to do is I'm going to use my order of operations, and I'm going to go ahead and solve it down. So you can see that I'm just continuing my simplification process here. And when I get to the very end, I should get that negative 92 is equal to negative 92. Now, if you got negative 92 equals another number like 7, well, then that means you made a mistake in your original problem. You should get to the bottom where one side is equal to the other side. That tells you that you got your answer as x equals 4 is 100% correct. Let's try another one. Okay, the next example has 2 opportunities to distribute. So I'm going to go ahead and I'm going to distribute everything on the left-hand side. So we have 2 times 1 is 2 minus 6p. Now, be careful. We have a negative 1 here. So now we have negative 1 times p is negative p. And then we have negative 1 times negative 4 is going to give us positive 4. And that is going to be equal to negative 8. I'm going to go ahead and combine everything. And you see that I have a 2 and a 4 that I can combine to give me 6. And then I have a negative 6p and a negative p to give me negative 7p. So I combined everything that I possibly could on that side. Now I'm just going to go ahead and I'm going to solve this 2-step equation. I'm going to subtract 6 from both sides. I'm going to cancel those out. I'm just going to give me negative 7p is equal to negative 14. And then I'm going to divide both sides by negative 7. And p should equal positive 2. But I want to check myself to make sure that I did that correctly. So I'm going to go ahead and I'm going to rewrite the original problem. And make sure you do rewrite it because it is easy to make a mistake and write something that maybe isn't there. And then it will cause the whole problem to be incorrect. All right, here we go. I'm going to multiply this 3 by 2. And then I'm going to say 2 minus 4 equals negative 8. All right, I'm going to go ahead and simplify inside my parentheses. I have 1 minus 6. And then I'm going to go ahead and condense this to negative 2. And then I'm going to continue my process here. I've got 2 times negative 5. And I just want to keep going. And you will see that at the very end here, I do get negative 8 equals negative 8. Again, negative 8 is not my answer. That's just saying, hey, you did the original problem right, and p equals 2 is 100% correct. Okay, now we have these things called special cases. So let's go ahead and solve these 2 problems because I have 2 different special cases to talk to you about. All right, this first multi-step equation looks like I have some distributing to do, so let's go ahead and get started. So I just distributed the first, this first piece, and I'm going to go ahead and distribute the second piece. Okay, now I'm going to go ahead and combine my like terms. So I'm going to go ahead and combine things that are on the right-hand side. So I have negative 58 is equal to negative 24n and 24n. Well, they actually cancel each other out, and they make 0, actually, which is kind of interesting. And that's going to, my negative 6 and my negative 48 are going to combine and be negative 54. You can see here that when I try to solve this problem here, I get negative 58 is equal to negative 54. Well, that is not true. So that's an impossible thing to happen. So this type of problem is called a no solution problem. And no solution is the technical way to actually answer this question. Things that would not work are NA or no. Those things wouldn't work. The actual way to technically say this is there is no solution to this problem. And because there is no solution to this problem, you cannot do a check step, because think about it. If we're trying to check if an answer works in the problem to make one side equal the other, you'd have to have an answer, and we don't have an answer here. So this is kind of a cool one where you don't have a check step. So I like to consider that a little smiley face. And my other type of special case looks like this. Let's go ahead and take care of this multi-step equation here. I'm going to go ahead and I'm going to distribute. Okay. And I'm going to go ahead and I'm going to combine my like terms. So you can see here that I have negative 24 and positive 24. So those are going to actually cancel out just like it did above. Coincidence that they were both 24. And then 18 plus 40 is actually 58. So 58 is equal to 58. So unlike the problem above, 58 actually does equal 58. So in this type of situation, the answer would be all real numbers. And what that means is any number that you choose, whether it be 0 or 10 or negative 25 or 364, any number that you choose, you can substitute it into these x's, and the left side of the equation will be equal to the right side every single time. So to check ourselves, this actually does have a check step because we have many, many, many answers. Any number should work. I always like to check using a very easy number. Let's use the number 0. So I'm going to go ahead and check my problem. And remember, what I'm going to do is I'm going to rewrite my problem. And then I'm going to substitute a 0 everywhere that I see an x. I'm going to go ahead and use order of operations and just do some simplifying here. If you're wondering why I chose to use 0, it's because, well, 0 makes other numbers, using the multiplicative property of 0, makes other things 0, and it makes things 0 pretty quickly. So I usually like to do that. And this does indeed give me 58. Now, I'll be honest, it is a very, it's a coincidence that this 58 and this 58 are exactly the same, because this number down here doesn't always need to be the same as the other. For example, I could have an answer like 7 equals 7, and it still works. All right, that is the end of this lesson on multi-step equations with one-step and two-step equations. And I would like you to keep in mind that I would like you to always use a check step for one-step and two-step equations as well. I only showed them with the multi-step because I just wanted to show you the process of solving one- and two-step equations. But I really would like you to be working with the check step as you go along.